guys, this is test 30 game 3. This is the car wash game. It's an ordering game. We know this because the cars are all washed one at a time, meaning that there must be an order in which they are washed. Now, I've laid out a lot of rules here and stuff. Don't worry, I'm going to explain all that. Ignore the bottom diagram for now, just look at the top one. We've got the 5 cars, FMOTV, and the types of washes R, S, and P. We know that the first car is not super, but at least one is, meaning that there is greater than or equal to 1 super. We've got exactly 1 premium. They tell us the second and third cars wash receive the same kind of wash. So I put down that 2 and 3 are equal on the cars level, on the washes level. We've got neither O nor T is before V, meaning that they're both after V because nothing is simultaneous. So V is before both O and T. Next, rule mentions O as well, so we can link it together. M is after O, and it is before F, meaning we have a general ordering O, M, F. And when we link that with the other rule about V, O, and T, we learn that V is before all of the others, meaning that V must be first. So V is first, then we have the general ordering O, M, F with T thrown in there somewhere. Now, the next rule tells us that we've got M is regular, and the car immediately before M is also regular, telling us that, if M was on 4, it would be regular, and the car before it would also be regular. If M was on 3, the 3 would be regular, 2 would be regular, and then this thing up here, of course, would also be a regular washed car. Now, this is a pretty bare bones diagram here, of course. We haven't put a lot down. We do know that, F can't be 2 or 3, O can't be 4 or 5, because they got to have things before them and after them. But I actually recommend now creating 2 different main diagrams based upon the placement of M, because M is the variable about which we know the most. M is involved in the sequence with all the other cars, and it's also the car that we know is regular. So we can make 2 different diagrams. Now I'm going to use the bottom one as well. We could have M on 3 on the top diagram and M on 4 in the bottom diagram. If M's on 3 on top, O must be on 2 because O is between V and M. On the bottom diagram, F must be on 5 in order for it to go after M. So now, M is regular, of course. The car before it's also regular, and because 2 and 3 are the same kind of wash, 2 must also be regular. Now in the top diagram, we know M's regular, and the car before it's also regular, both due to this rule over here, as well as due to the rule that 2 and 3 have to have the same kind of wash. Now we've locked down a lot of the things that are certain here. I'm going to fill in some other things. If M is on 3 on the top diagram, we have F and T interchangeable on 4 and 5. Either we have F on 4 and T on 5, or we have T on 4 and F on 5. In the bottom diagram, we could have either O on 2 and T on 3, or we could have T on 2 and O on 3. Now, in the bottom diagram, remember that we have to use all types of washes at least once, because regular is always occurring due to the M rule over here. There's always exactly 1 premium, and there's always at least 1 super. So in the bottom diagram, because 1 cannot be super, it will have to be premium, leaving 5 to be super. In the top diagram, 1 cannot be super, of course, so we know it's either premium or regular, although we don't know exactly which one it is. Then we know that because super can't be on any of 1, 2, or 3, we will have to have super at least either on 4 or 5, and of course, perhaps both. If 1 was regular, we'd have 1 of 4 or 5 being super, 1 being premium. If 1 was premium, these could both be super for all we care. At least one of them just has to be super. So you could leave things here and jump into the game if you want, or if you like, you could actually flesh out the top diagram further, breaking it apart into 2 different possibilities based upon whether 1 is premium or 1 is regular, giving you 3 main diagrams. I'm not going to bother doing that here just because I think most people won't want to, but if you do want to do that, feel free. So this is our initial setup for the game. Now question number 11, typical orientation question. Just take 1 rule at a time, apply to all 5 choices, looking for violations to eliminate, working by process of elimination. So, of course, we know that V is always first, so for that reason, A can be eliminated since it is not V there. We know that 1 cannot be super, so anything with 1 being super is gone. getting rid of D. Next, we can use the rule that M is always regular. So scanning through the choices, that all checks out, no violations. We can also use that the car before M also has to be regular. Again, unfortunately, no hits there, no violations there. We can use the sequence as well. We know that V is before O and T, and O is before M and F. So let's use the general sequence O, M, F, scanning through the choices B, C, and E which remain. Let's see, B is good on that issue. C is not good on that issue. C has M before O, which is unacceptable, so C is eliminated. E has the general ordering O, M, F, which is fine. Now we have B and E remaining. And we do know that we have to have exactly one premium, so let's check for that, compliance with that limitation. We find that B is good on that issue and E is good on that issue. We know that we have to have at least one super. We find that B is okay on that issue, having super on 5. E is not okay on that issue, having no super at all. So E is gone, leaving B as your answer for number 11. Next, number 12, if V did not receive a premium wash. So we know the bottom diagram is irrelevant in this case, since V must be premium in that scenario. The top diagram, we're going to have V be regular, so I'm crossing off the premium. Since we have 3 regulars here, we know that 1 of 4, 5 will be super, and 1 of 4, 5 will be premium. So I'm putting down S/P for both of those. Now we'll run through the choices. For must be true, must O and V have the same kind of wash? Yes, they must. They are both regular, so A is our answer for number 12. I will look at the rest, though. Must M and T have the same kind of wash? No, in fact, they cannot because M is regular, and neither 4 nor 5 could be regular, which is where T is going, so B is gone. C, 4 is premium. That could happen, but does not have to. 4 could be S, and 5 could be P, so C is gone. Looking at D, O is 3. No, O is specifically 2 in this case, so D is gone. Looking at E, M is 4th. That's impossible. M must be 3rd, so E is gone, leaving A as our answer for number 12. Next, number 13, if the last 2 cars have the same kind of wash. So that's not happening on the bottom diagram since R is 4 and S is on 5. We'll have to use the top diagram, and we'll have to make 4 and 5 the same type of wash, which of course means both of them would be super for certain. So I'm crossing off the slash here, and we're going to have to make one premium because we've got to have a premium somewhere. So it's P, R, R, S, S for 1 through 5 on the top level. What could be true? Could O be 3? No, M is 3, A is gone. Could T be 5? Yes, that could happen. T could be 5, and F could be 4. So B is our answer for number 13. I will look at the rest, though. Could T be before M? No, M is before T, so C is gone. Could V be regular? No, V is premium in this case. That was an initial limitation we found. And could there be exactly one S? No, there's exactly 2 S's on both 4 and 5, so E is gone, leaving B for number 13. Next, number 14, what must be true? In general, looking at all the scenarios here. Must V be premium? It is on the bottom, but V could be regular on the top scenario, so A is not a must. Must exactly 2 supers appear? No, we see in the bottom diagram we could have only 1. Also in the top we could have only 1 as well. If we had P on 1, we could have R, R, and then S or P interchangeable. If we had, R on 1, we could have S and P interchangeable there. So lots of ambiguity. Those aren't even the only possibilities for the top diagram, so we clearly could have only 1 super, so B is gone. Next, looking at C, could 5 be super? In the bottom it is. In the top, it could happen, but again, 5 could be premium, 5 could even be regular, so C is gone. Looking at D, 4 be super. That could happen in the top, does not have to. It could be P, could be R. In the bottom diagram, of course, 4 could be R, so D is gone, leaving E by elimination. And if we look at E, 2 being regular, of course, we have that in both of these scenarios, all scenarios for the game, we have R being on 2, so E is our answer for 14. Next, number 15, which are all the cars that have to be regular? Of course, we see that O is always regular, whether it's on 2 or on 3. We know M is always regular, whether it's on 3 or on 4. Everything else has a great deal of ambiguity. Vinketta V could be premium, F could be super, could be premium, and T could be super or premium. So for that reason, O and M are the only 2 that have to be regular at all times. Therefore, B is our answer for number 15. Next, number 16. They're adding a new rule to this game. They are fundamentally changing the rules of the game, adding in this variable J. Now, J could appear pretty much anywhere, there are no rules regarding the placement of this car. So everything is thrown into flux. The original rules no longer apply. So what do? Well, they're asking us what cannot be true. So apparently J's introduction causes something to be impossible. And so we want to think about, well, what was already impossible out of these choices, because something that was already impossible perhaps would still be impossible. So it's a good starting point to look at. Now, scanning through the choices, choice A happens to jump out at me because O premium is a very difficult thing to achieve. They're saying we have O as getting a premium wash. Now, we know that there's only one premium in the game, and O is a very limited variable. It's got to be between V and M, so it's rather limited in its placement. Looking at the previous state of affairs, O was always on either 2 or on 3. And the reason for that, of course, is that we could have T going before O, T going after O, but O is always regular because of the fact that 2 and 3 were the same kind of wash, and also because of the fact that M is regular and the car before it was also regular. So let's see what would happen if we introduced J. Could we ever have O be premium? So here's a new main diagram. I put 6 slots in because J would be the 6th car. Now the only place that O could feasibly go is on 4. Because there's only one premium in the game, O cannot go on either 2 or 3, because then we'd have 2 premiums. O can't go on 1 because V's got to go before it. O can't go on 5 or 6 because M and F have to come after it. So the only place I even imagine that O could appear would be on 4. At least the only place I could imagine that O would seem to appear to be possible, where O might go. So we have O here. We're going to have M on 5 and F on 6. Now, 2 and 3 have to be the same kind of wash. Maybe they're both regular, maybe they're both super. Of course, they're not both premium. Now, the problem that results is that M has to be regular. So M's regular, and the car before M is also regular. That's where the problem arises. O on premium could not be on 4 because we need to have a regular here due to this rule. So there is no good place for O to be premium. Therefore, it is never possible for O to be premium. And as such, A is our answer to question number 16.